The reactions of haloalkanes were of two types. There were two types of reactions of haloalkanes. One was substitution, and other was elimination. Elimination, in which the hydrogen and halogen of an alcohol was eliminated to make an alkene. But as I told you, there was no mechanism for this elimination, but we had the mechanism for the substitution. There were two mechanisms with the substitution followed, SN1 and SN2. Right? Nucleophilic substitution unimolecular and nucleophilic substitution bimolecular. Okay? SN1 and SN2. So SN1 is when one two-step, and SN2 is one step. Okay, so it is two-step, it is one step. Okay, so it happens in what? SN1 happens in tertiary, and this happens in primary. Okay, rest of the detail we have already gone through. Okay, now we are going on. Okay, this substitution reaction when happens, for example, if I write 3 halogen, for example, if this is chloro, if this is bromo, and if this is iodo, right? And we reacted with, let's say, OH negative aqueous. You know, OH negative aqueous is a nucleophile that comes and takes the place of, let's say, हम इसको NaOH से react करा रहे हैं aqueous से. So you remember all this detail we have already done. It comes and takes the place of Cl. So what is the product? C, 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 and then OH. Right? Similarly, if I react it with bromoalkane, what happens? C, 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 and then instead of this comes OH. Is it clear? Similarly, if you look at this, this becomes OH. So now today we are going to see chlorobromoiodo. Does it make any difference to the reaction rate or speed when there is Cl, when there is Br, or when there is I? Is there any difference? Yes. Because, look, CCl bond length is less because of a small radius of Cl. CBr bond length is more as compared to Cl because of increase in atomic radius of Br. And on the other hand, or similarly, the iodine bond length is even more. When bond length increases, we have learned in bonding, when bond length increases, orbital overlap decreases, right? So there is a less nuclear attraction between the opposite electrons. So bond strength also decreases. So what we expect, are they going to be replaced at the same rate, or the iodo one will be the fastest? Yes. So this is what we need to learn. Okay, in haloalkanes, as you go, in halogens, as you go down the group, atomic radius increases. Because of that, the bond length with the carbon also increases. Hence, the rate of nucleophilic substitution also increases, right? And this is basically evident by adding silver nitrate and their test. But as I told you a while ago, because we are going to discuss the test in the next section. So yahan pe I'll stop this. So complete topic here कि they ask you, okay, first you tell us the logic. Okay, why does the rate increases? Yes. Why it increases? Because of increase in the bond length, bond strength decreases, and then they ask you give the evidence. Evidence ये है कि halogen का test करते हैं ना silver nitrate से, तो white precipitate, off white और yellow precipitates आ जाते हैं. ठीक है? वो yellow precipitates are the one which come very quickly. मैंने आपको 3 haloalkanes दिए, chloro, bromo, and iodo. I asked you to put silver nitrate in all of them. If white precipitate chloro, if off-white bromo, if yellow is ido. But you notice one thing, okay, मैंने एक ही टाइम पे तीनों में सिल्वर नाइट्रेट डाला, but yellow precipitates come quickly. All the off-white and white also came, but they came slowly. That was the basically evidence. Okay, so please write down the the rate of nucleophilic substitution. The rate of nucleophilic substitution in haloalkanes increases with the increase in increases the rate of nucleophilic substitution reaction increases with the increase in sorry the rate of increases with the increase in bond length of CX. X mean halogen, okay? In halogens, down the group, atomic radius increases. So as the CX bond length hence bond strength decreases. Therefore, the rate of nucleophilic substitution reaction also increases. Bond length increases, hence the bond strength decreases. Therefore, the rate of nucleophilic substitution reaction also increases. It is easy to replace now. Okay, this is the evidenced by appearing the yellow precipitates with silver nitrate quickly as compared to the off-white and white precipitates. Okay, but as I told you, वो chemistry क्या है वो yellow precipitates की वो will discuss in the next section. Yes, bond strength कम होगी, so जल्दी bond break हो जाएगा. So because the whole is this bond का breakage. You know, heterolytic fission होगी, ये bond टूटेगा तो OH आगे आ लगेगा. So जितना ज़्यादा जल्दी ये bond टूटेगा, you remember this जो mechanism था कि COH bond, CCl bond break होता है, फिर वो आगे जाता है. Okay. Okay, that's all about the haloalkane. Now we are moving on to the alcohols. As I told you कि जो reactions है ना tests हैं वो सारे हम एक साथ करेंगे. ठीक है, टेस्ट ऑफ फंक्शनल ग्रुप्स. तो वहां मैं आपको बताऊंगा कि सिल्वर नाइट्रेट डालने से ये तो आपको भी बता दिया कि येलो ऑफ वाइट और व्हाइट प्रेसिपिटेट्स आते हैं और किसके प्रेसिपिटेट्स क्विकली आएंगे येलो, फिर ऑफ वाइट और सबसे स्लोली किसके आएंगे व्हाइट. बट क्या केमिस्ट्री है उसके रिएक्शंस क्या है विल डिस्कस इन दैट सेक्शन. ओके, नेक्स्ट हेडिंग दे अल्कोहल्स. CnH2n plus 1 OH or CnH2n plus 2O. Jenna formula. Functional group we all know is OH. Okay. We have discussed isomerism and naming, preparation of alcohols. How the alcohols are prepared. Now, if I write the reactions, only the headings, you have to copy the reactions yourself. Preparation में, please pay attention. Preparation में पहला था starting from alkane. Think of the reaction of alkane. तीन थे. Combustion, substitution, and cracking. None of them were giving alcohol. Okay. Now come to the alkenes. Alkenes के reactions, think of combustion and then addition. Yes, addition में एक reaction था जो alcohol दे रहा था. Hydration वाला, right? तो पहला हो गया hydration of alkene. इक्वेन आप खुद कॉपी करेंगे. दूसरा हो गया you remember वो 350 H3PO4 and all that. Okay. The second one was mild oxidation. उसमें भी तो अल्कोहल बन रहा था, याद है? डायोल बन रहा था. Mild oxidation of alkene. Third one was third one. अब एल्कीन के मेरा ख्याल यही दो रिएक्शंस थे. Okay, the third one, haloalkane. Yes, haloalkane में nucleophilic substitution with NaOH aqueous and KOH aqueous के साथ भी क्या बन रहा था? Alcohol. So please write down third हो गया SN, nucleophilic substitution of haloalkanes. One lines you have to leave. Every time you have to leave a line because you have to copy the reaction from the previous part. ठीक है, वो मैंने वहां करा दिया, या मैं दोबारा नहीं करा रहा, आप वहां से कॉपी कर ले बस. SN of haloalkanes, nucleophilic substitution reaction of haloalkane with NaOH aqueous and KOH aqueous. They were also giving the product alcohol. इसके अलावा number 4, from aldehydes and from ketones. And from carboxylic acid. These three, again, you have to leave one line because these are the reactions yet to be discussed. And in all three types, by reduction. Okay, you just copy this. First, again, first three reactions, you have to copy, we have already done. The next three reactions, we are yet to do them. So please just leave one line empty. So जब हम कर लेंगे, you can come back and put the reaction here. पहले वाले जी, वो फिर वही रिएक्शंस, जैसे पहले पीछे जाइए, आई कैन पॉइंट आउट कि कहां से कॉपी करना है. प्रिपरेशन ऑफ एल्कीन में जाइए. प्रिपरेशन, कैन यू किड्स गो टू प्रिपरेशन ऑफ एल्कीन एवरीवन? प्रिपरेशन ऑफ एल्कीन में एल्कीन्स की प्रिपरेशन में preparation of alkenes, what were the headings? Number 1, preparation, reaction the preparation of alkenes by cracking, dehydration, elimination of. Now we have done this reaction in haloalkanes. Now you copy the reaction of haloalkane elimination which we did in the reaction of haloalkane and paste it here. इसी तरह अब ये भी करना होगा. आई एम ट्राइंग टू मेक यू लर्न कि ये जो मैं खाली छुड़वाता हूं इसका क्या मतलब है. एल्कीन की प्रिपरेशन में मैंने कहा था ना कि एल्कीन हैलो एल्कीन से प्रिपेयर होते हैं बाय द एलिमिनेशन. जस्ट लीव द वन लाइन. नाउ व्हाट यू हैव टू डू, अभी आप जाइए हैलो एल्कीन के रिएक्शन में, वहां एक रिएक्शन है ना जिसके एलिमिनेशन से एल्कीन बन रहा है, वो रिएक्शन वहां से कॉपी कीजिए और यहां पेस्ट कर दीजिए. कट नहीं करना, कॉपी एंड पेस्ट. ओके, अब समझ आ गई है? तो यहां भी यही करना है. हाइड्रेशन ऑफ एल्कीन हमने किया हुआ है ना, वो वहां से कॉपी करके यहां क्या कर दो, पेस्ट कर दो. ओके, कमिंग टू द रिएक्शंस. Reactions of alcohols. Reactions of alcohols. The first one for all, just like alkanes and alkenes, combustion. You know what happens when the alcohol combusts? Just like alkane and alkenes, जब ये combust करते हैं, जैसे ethanol, when combust in oxygen, there are two ways to combust. कौन से? Excess में और limiting में. What is formed? If it is burned in excess and in the limited supply, क्या होगा? What happens? जब excess में burn करेगा तो क्या बनेगा? Carbon dioxide and 2CO2, 3H2. ऐसे ही है? Balance it, 2 to 4 or 3, 6, 3O2. But when there is a limited supply, what is formed? Carbon mono and what is the product? 2O2. So one is complete combustion, another one is incomplete combustion. Number 2, reaction with Na metal. Now, alcohols are the organic compounds which react with metals, and not all the metals, the group 1 metals, especially the sodium, right? So when they react with the sodium, look at this. If I take, for example, CH3OH, please pay attention now, it's important. This alcohol is what? Methanol. When I react with sodium metal, it looks like a reaction with acids and metal. Because we remember in O levels, we learned that when metals react with acid, तो उनके H को displace कर देते हैं. Same thing happens here. The sodium metal comes and displaces the H. It's not going to attack the OH. It's going to attack the H and substitutes it. So what is the product form? CH3O negative and Na positive. So there is a salt that is formed, right? And the salt name is methanol से ही derive होगा. The salt name is sodium meth oxide. It's an organic salt. Positive negative sign, I just showed it to you कि ये पता चले it's an ionic compound. Okay? आप ना भी लिखें तो खैर है, but लिख लें ताकि आपको भी idea. So जो hydrogen gas निकली है, that is in the form of hydrogen gas, H2. And this reaction is very fast, very vigorous. So the hydrogen gas that is evolved, it evolves with effervescence or fizzing. Okay? Similarly, if I give you half minute balancing के लिए लगा है. For example, you have to complete it, बच्चों. C2H5OH plus Na. What is formed? It is ethanol. So it's going to displace what? Hydrogen. What is formed? C2H5ONA. Again, it's an ionic compound, a salt named as sodium ethoxide, along with hydrogen gas. Now, if I take ethanediol and but you reacted with Na, what is formed? Obviously, both these hydrogens are gone. 2 moles of Na you need. Okay, so the salt that is formed is CH2, CH2, ONA. and ONA, right? So basically, plus not half, this time H2 gas. So basically, it is like this. CH2, CH2, O negative on this side, O negative on this side. So this is a two negative ion. Okay? This is a two negative ion, जिसके दोनों साइड पे फिर Na आके अटैच हो जाता है ना, फिर तो एक ही जगह होगा. ओके, नाउ व्हाट द एग्जामिनर्स डू, वो इसमें आपके लिए भी एक मुसीबत खड़ी कर देते हैं, और दैट हार्डशिप इज कि वो इसमें मोल्स डाल देते हैं. अब वो कैसे मोल्स डालते हैं वो सुनना जरा, मैं आपको उसका एक आइडिया दे देता हूं. वो मोल्स ऐसे डाल देते हैं कि आप एक चीज जरा नोटिस करें कि क्या रेशो आ रही है. इफ लुक एट द मैथनॉल बच्चों, इफ यू लुक एट द मैथनॉल व्हिच आई जस्ट शोन हियर, व्हेन मैथनॉल का एक एच था या एथेनॉल का एक एच था, तो हाउ मेनी मोल्स ऑफ हाइड्रोजन गैस प्रोड्यूस? हाफ मोल. ऑन द अदर एंड जब डायोल थी, लुक एट द रिएक्शन नंबर 3, जब इट वाज अ डायोल तो कितने मोल ऑफ हाइड्रोजन गैस बनी? तो वो इसको रिलेट करते हैं कि अगर मैं आपको इन अ रिएक्शन, इफ आई गिव यू द वॉल्यूम ऑफ हाइड्रोजन गैस, आप उसको मोल्स में कन्वर्ट कर लें, ठीक है, एंड आई गिव यू द मास ऑफ एथेनॉल, आप उसको भी मोल्स में कन्वर्ट कर लें. इफ द रेशियो इज 1:1/2, यानी 1 mole of alcohol giving half mole of oxygen gas, it means there is a 1 OH in this alcohol. If, as in this particular case, what is the ratio? 1 mole of alcohol produced how many moles of hydrogen? 1 mole of hydrogen gas. So it means it contains 2 OH. At time I gave you, okay, there is an alcohol, please pay attention. There is an alcohol, right, that is producing 1 mole of that alcohol, giving, for example, 1.5 mole of hydrogen gas. If the ratio is this, then what does it mean? Yes, then the compound which I figured out was like this. Look, there was OH here, there was OH here, and there was OH here. Right? So this is the compound that gave 1. So I hope you got my point. Right? The number of moles of alcohol, you have to relate with the number of moles of oxygen gas that is produced. अब वो दोनों वैल्यूज आपको दे देंगे. They will give you the volume of hydrogen gas. उसको 24,000 से डिवाइड करोगे तो क्या आ जाएगा? उसका वॉल्यूम मोल्स आ जाएंगे. और they will give you the mass of alcohol. उसको उसके MR से भी दे देंगे. MR से डिवाइड करोगे तो क्या आ जाएंगे? मोल्स. फिर उनको जस्ट रिलेट करना है. If ratio is so 3 ratios I have told you. Again I'll repeat: 1:1/2, 1:1, and 1:1.5. So 1:1/2 mean 1 OH, 1 OH. 1:1 mean 2 OH groups, functional groups, and 1:1.5 mean, and 1:2 mean. Okay. So when we'll do the past paper questions, we will solve it. Okay. But I told you straightforwardly, दोनों का क्या given होगा आपको? दोनों के mass और volume given होगा. You just have to find immediately number of moles, और फिर दोनों को आपस में ratio करना है कि simplest ratio क्या आ रही है. 1:1 है, 1:0.5 है, 1:1.5 है, 1:2 है. जो भी रेशियो आएगी that will tell you कि OH कितने हैं. याद क्या रखना है कि अगर 1 OH हो तो आधा मोल हाइड्रोजन गैस बनती है. कितने मोल हाइड्रोजन गैस बनती है? हाफ मोल. राइट. सो ये सवाल इज सो इंपॉर्टेंट, 3 दफा आ चुका है इन द लास्ट 5 years. ओके, नेक्स्ट. Next is, and this reaction, sorry, one more thing, this reaction is known as a redox reaction. This reaction is known as redox reaction. This with metal, with any metal, the type of reaction is redox. Okay. बिकॉज यू अंडरस्टैंड सोडियम 0 से +1 हुआ है तो उसकी क्या हुई है, ऑक्सीडेशन, और वो -1 हुआ है तो उसकी क्या हुई है, रिडक्शन. ओके, next one is please parents, the next is, okay, parents please, the next is substitution reaction of alcohols. Substitution reaction of alcohols. Now please pay attention. Now please pay attention. If this is CH3OH, please pay attention. If I react it with the PCl3, which is known as phosphorus trichloride, if I react it with PCl5, which is known as what? Phosphorus pentachloride, and heat it, okay? Or if I react it with SOCl2, known as thionyl chloride, okay? Even if I react it with, for example, HX, HX mean you understand, HCl हो गया, HBr हो गया, etc. Okay, but when I react with HCl or HBr, I have, or sorry, or I react it, these are the gases, okay, or I react it with KCl. KCl mean potassium chloride. But in this case, I have to take concentrated H2SO4 or concentrated H3PO4 as a catalyst. Okay, concentrated H2SO4 and concentrated H3PO4 as a catalyst. Now look at this, what happens. In all these reactions, why I clubbed them together? In all these reactions, the alcohol are going to lose their OH. Not lose their OH precisely, they are going to substitute their OH with the halogen. क्योंकि इन सब में एक common चीज है. What is that common thing? Halogen. So in all these compounds, the halogen will come and take the place. That's why I clubbed them together. So in all these reactions, we know the organic product. Just OH को हटाना है और कहाँ क्या लगा देना है वहां पे, Cl लगा देना. So that's called a substitution reaction, right? The complete OH function group is gone. For example, in this case, तो पहले में product क्या होगा? CH3, OH की जगह कौन आ जाएगा? Cl. दूसरे में क्या होगा? CH3, OH की जगह कौन आ जाएगा? Cl. In the third one, CH3, what is the Cl? In the fourth one, CH3, Cl. And even in the last one, CH3, Cl. The difference is the byproducts. The other products that are going to form, they are different. You have to just memorize them. There's no logic to understand here. The other product is H3PO3. The other product is POCl3 and HCl. Here HCl comes out in the form of steamy fumes. So ये later on we'll learn कि ये test भी है alcohol का. ठीक है कि अगर PCl5 डालने से steamy fumes आते हैं, that indicates the presence of alcohol functional group, right? Plus in this case SO2, thionyl chloride, okay? In this case SO2, and in this case plus H2O, and in this case plus, right? So इसको लिखें जरा. In all these cases, this is CH3OH, this is again CH3OH, this is again CH3OH, and this is again CH3OH. Heat. No, heat is with this, and जहाँ ये No heat. ये जो HX वाला है, मैं एक्सप्लेन कर रहा हूँ। मैंने एक HCl का साथ लिखा है, HBr के साथ भी लिख सकते हैं। जी, यस। प्लीज राइट द बाय प्रोडक्ट्स। जी, H2O, H2O. And the last one is H2O. Basically, please write down. Please pay attention. Pay attention. In this case, if I explain it to you, actually this reaction happened like this. KCl reacted with sulfuric acid to form KHSO4 and HCl. That HCl came and take the place of. यानी ये रिएक्शन बेसिकली ये इसी रिएक्शन इसमें पहले HCl जनरेट हुआ और फिर रिएक्ट, राइट? बट सल्फ्यूरिक एसिड के प्रोडक्ट हम साथ नहीं लिखते, ओके? बाय प्रोडक्ट्स हम साथ नहीं लिखते, बट एक्चुअली दिस रिएक्शन इज HCl is generated and then HCl reacted again to replace the OH of the Cl. तो बैलेंस तो कर लेंगे ना आप, यू कैन बैलेंस इट आउट। सॉरी, मैंने कहा वो उसके प्रोडक्ट्स नहीं लिखे ना हमने, वी जस्ट राइट द मेन प्रोडक्ट्स। नहीं, हाँ, KHSO4 लिख लोगे साथ, लेकिन जरूरत नहीं है उसकी। ओके, राइट डाउन। सो ये भी प्लीज लिख लीजिएगा, दिस रिएक्शन, these steamy fumes, they give right as a test of functional group. So I give you one more reaction here. If it is ethanol C2H5OH plus PCl5, can you please complete this? Please write the product. Okay, fine. So what is the product when PCl5 reacts with this? क्या product बना है? C2H5Cl plus POCl3 plus steamy fumes of HCl. This reaction is also used as a yes. So in the next step, इसमें भी साथ चलें, HCl लिख लें इस वाले में भी, plus HCl. In thionyl chloride, please write HCl. Right, so these are the steamy fumes of HCl. They are used as a test for the functional group of alcohol, right? To identify the alcohol functional group, there is a liquid, you put the steamy fume, PCl5, a solid, white solid, and then steamy fumes come out. That indicates that liquid is alcohol, right? Next, reaction of alcohols. Next, reaction. Next is, sorry, dehydration of alcohol or elimination. Look at this, for example. Pay attention, everyone. This is important. If I have an alcohol here, we have done the elimination in the haloalkane wale section mein. It's almost the same thing which we did there. कि इसमें जो अल्कोहल है वहां पे इफ यू रिमेंबर तो क्या एलिमिनेशन में होता था, एक कार्बन से Cl जाता था या हैलोजन, और उसके एडजेसेंट कार्बन से कौन चला जाता था, H, और इन्हीं दोनों के बीच क्या बन जाता था, डबल बॉन्ड. सो इट्स द सेम थिंग. सो एलिमिनेशन रूल इज द सेम कि ये कार्बन से OH जाएगा, नॉट द सेम एडजेसेंट कार्बन से कौन चला जाएगा, एडजेसेंट मीन नेबर कार्बन से H, और इन्हीं दोनों के बीच क्या बन जाएगा, डबल बॉन्ड बन जाएगा. सो स्ट्रेट फॉरवर्ड द सेम एलिमिनेशन लाइक दिस. तो आप कहते हैं जी ये तो वापस क्या बन जाएगा, इथीन इज फॉर्म्ड. तो आप कहते हैं व्हेन देयर इज अ डबल बॉन्ड प्लस H2O, राइट. हाँ, उसमें अगर आपको याद हो तो क्या, व्हाट वाज द रिएजेंट एंड कंडीशन फॉर दिस, किसी को याद है व्हाट वाज द रिएजेंट एंड कंडीशन फॉर दिस, क्या थी रिएजेंट एंड कंडीशन, NaOH अल्कोहलिक और KOH अल्कोहलिक, बट नॉट हियर. यहाँ इसके अपने रिएजेंट के, द ओनली डिफरेंस, द रूल इज द सेम बट द रिएजेंट कंडीशंस are not the same, right? For this reaction, for alcohol, we need either aluminum oxide and heat, or you can also use concentrated sulfuric acid. Aluminum oxide is the catalyst, okay? It just catalyzes the reaction. Aluminum oxide, catalyst and heat, or concentrated acid. Concentrated, let's say, sulfuric acid and heat. तो कंडेंसेशन डिफरेंट होता है, वो दो मॉलिक्यूल जब जुड़ के कोई छोटा मॉलिक्यूल वाटर निकलता है तो उसे कंडेंसेशन कहते हैं. ठीक है, इट्स एलिमिनेशन. एलिमिनेशन में उसी मॉलिक्यूल के अंदर से कुछ एलिमिनेट हो जाता है, सम स्मॉलर पार्ट हैज बीन एलिमिनेटेड. अब इसमें जो मैंने वहां नहीं कराया था यहां कराने लगा हूं कि अगर फॉर एग्जांपल, नाउ यू हैव टू पे अटेंशन इन दिस रिएक्शन, और ये हेलोअल्केन में भी यही चीज होगी, बट आई एम गोइंग टू टेल यू राइट नाउ. मैंने सोचा था वहीं जाके बताऊंगा कि इन दिस केस इफ यू हैव फॉर एग्जांपल, प्लीज पे अटेंशन, अगर तो OH इज एट कार्बन नंबर 1, फिर तो केस डिफरेंट होता है. देन देयर इज ओनली वन प्रोडक्ट फॉर्म. अगेन आई एम सेइंग, if the OH is present on terminal carbon, so then there is always one product formed. But if the OH is not on terminal carbon, जैसे इस केस में for example, if OH would have been at one carbon, if it is butane 1-ol, pay attention, अगर ये butane 1-ol होता तो आप कहते हैं इसके adjacent में तो there is only one carbon here, and that carbon has how many hydrogens? 2. But when alcohol OH is not on the terminal carbon, it is in the middle of the chain, तो फिर तो इसके दो neighbors हैं, this one and this. So इसका मतलब है कि when it loses its OH, it has two options. It can lose hydrogen from this side, तो double bond यहाँ बनेगा. So what type of alkene is going to be formed? But 1-ene. If they lose, let's say, OH from this side, from carbon number 3, right? If they lose from carbon number 3, तो फिर double bond कहाँ बनेगा? But 2-ene. So in this case, and you don't know कहाँ से जाएगा, kind of equal opportunity. So it means जब butane 2-ol की elimination होगी, तो there'll be but 1-ene and but. अब examiner ये last year question आया, अब सुनिएगा गौर से. They ask if butane 2-ol is dehydrated or eliminated to give 3 isomeric products. 3 isomeric products. अभी तो हमने कहा है 2 बनेंगे, तो आपने कहा हाँ 3 बनेंगे because we are forgetting about the cis trans isomerism. Whenever there is an alkene, there is a cis and trans isomer. सो आप कहते हैं yes there are possibility of 3 clearly. एक तो हो गया butanene, but butanene cannot have cis trans isomerism. You know, guanine cannot have cis trans isomerism. But if there is a butene, butene कोई चीज नहीं है. अब हमें पता है कि butene exists in the form of cis butene, and so how many isomers then? 1, 2, 3. सेम गोज विद हैलोएल्केन्स की, राइट. तो आप याद रखिएगा, वो आपको यही कहेगा कि एक अल्कोहल है, उसकी डिहाइड्रेशन की है, 3 आइसोमेरिक प्रोडक्ट बन गए. आप जो ही एल्कीन बनती है, आप सोचिए यार जो रिजल्टेंट एल्कीन है उसका सिस ट्रांस चेक करना है, और ब्यूटवानीन में सिस ट्रांस नहीं होता. बट ब्यूटूइन, नाउ प्लीज फ्रॉम हियर ऑन यू मस्ट थिंक लाइक दिस कि ब्यूटूइन दुनिया में कोई चीज नहीं है. ब्यूटूइन इज नथिंग. व्हेनेवर ब्यूटूइन इज फॉर्म्ड, इट आइदर फॉर्म्ड लाइक दिस or like this. I mean, both are on the similar side or both are on the opposite side. So there is no butene. Butene is always existing in the form of cis and transbutene. Whenever there are 2 molecules of butene in a beaker, one of them would be cis and another one would be trans. So whenever you have 1 mole of butene in a beaker, it is आधा cis और आधा trans. So butene कोई चीज नहीं होती दुनिया में, right? They exist in the form. So therefore whenever you do the elimination, फिर वो कभी कभार ये भी दे देते हैं, कहते हैं ये एक अल्कोहल है. Now listen carefully. This is an alcohol. Please pay attention. Now this is a tricky question. This is an alcohol. What will be the product when this alcohol is eliminated? If I pass it through aluminum oxide and heat, what is the organic product formed? What is the structure of organic product formed? जिस कार्बन से OH जाता है, रूल क्या है कि एल्यूमिनियम ऑक्साइड एंड हीट किया है, एलिमिनेशन करनी है. जिस कार्बन से OH जाएगा, साथ वाले से क्या जाएगा? H. साथ वाला ये है बच्चों, उसके पास H है ही नहीं. इस केस में आप कहते हैं देयर इज नो रिएक्शन. ओनली एडजेसेंट, ओनली नेबर, नॉट द होल मार्केट. नो, जस्ट नेबर. नेबर पे हाइड्रोजन नहीं है, सो देयर इज नो रिएक्शन. ओके, सो कीप इन माइंड, हैलोएल्केन में भी एंड अल्कोहल्स में भी इस तरह के क्वेश्चन आएंगे एलिमिनेशन से रिलेटेड, राइट. दैट्स ऑल फ्रॉम माय साइड. थैंक यू.